Okay, so we just got done talking about mutually exclusive events. So that's this column right here. What I want to try to do is take my calculation right here, okay? And I'd like to move it up here, okay? And so I'm going to say 68 over 102 plus 24 over 102 equal 92 over 102. I'm not reducing that fraction for now, okay? So that's what you do when you have mutually exclusive events. Let's look at the situation over here. This was not mutually exclusive, not, right? That's why we put it over here in this column, okay? So because it's not mutually exclusive, we're going to use a slightly different rule. We're going to figure out the number of sevens in the deck, okay? So if you're not a card player, there's 4 sevens in the deck of 52 cards. We're going to figure out how many red cards there are. So we're going to add to that 26 out of 52. And when we do that, if we added these two up, these two probabilities, we would have counted the ones that I had talked about earlier. This card right here, the 7 of hearts and the 7 of diamonds, gets counted twice. So the way you take care of that is you subtract the number that got counted twice. So we counted those two cards twice, the ones that are happening at the same time. That's what makes this not a mutually exclusive event. So the modification on the addition rule is you add the probability of sevens, you add to the probability of red cards, and then you subtract the probability of when they're in common, when they do both at the same time, red and 7. Okay, so 2 out of 52. All right, so how does that come out to be? The 30 out of 52 minus 2 would be 28 out of 52, I think. 28 out of 52. So you can see it got a little bit more complicated. And now we need to, probably pay attention to the rule. Over here, maybe the things are so easy. You're like, hey, I don't really need this special rule. I could just figure out there's 4 threes, there's 4 twos. I'm going to add them together, say 8 out of 52. But over here, because there's this commonality between a 7 and a red card, there's 2 that are in common. You do need to pay attention to that a little bit. So we're going to subtract that, right? Let's look at this one. What's the chance of drawing a queen or a spade? Okay, so what's the chance of a queen? So that's there's 4 queens in the deck of 52 cards, right? And there are 13 spades. So I'm going to put plus 13 out of 52, okay? But one card, a queen of spades, got counted twice. So the one that's in common, right, that makes it not mutually exclusive, you subtract that. So that's going to be 1 out of 52. And when we do that, I think we're going to get 16 out of 52. All right, let's try one more not mutually exclusive situation where you got to subtract what they call the intersection, what's in common or what's happening at the same time, okay? A game piece is selected at random from a plate at the right. What is the probability the game piece is round? So let's just deal with one at a time, okay? So round, all right, so let's look for the round ones. 1, 2, 3, 4, 5. I think there's 5 round ones out of 6, 7, 8, 9, 10. I think there's 10, right? So there's 5 out of 10 that are round. All right. The next one is what's the chance, that you draw an orange one? What's the probability that we draw an orange one? Well, how many orange ones are there? 1, 2, 3, 4. Okay, so I'm going to add to that 4 out of 10. Now, because it's not mutually exclusive, there are round ones that are orange. So both are occurring at the same time. That's what makes it not mutually exclusive. We're going to subtract that number. We're going to subtract how many are, oh good, my pen's working still, that are both round and orange. So there's 2 that really got counted twice, and that's why we're subtracting them out. And so we get 9 minus 2 is 7, 7 out of 10. All right. Hey, I hope I'm making this situation clear, not mutually exclusive. Please try the rest of the homework problems. I'm going to be walking around answering questions in class. Thanks for watching.